Okay, so the analysis section has a lot going on in it. In this case, since we're performing a series of calculations, we're not really testing a hypothesis, we're seeking the answer to a question. It's going to be a little different than it would be in some types of experiments. But here are the main things. You're going to explain the results of your calculations. So in the calculation section, we just had the formulas, had the numbers, had the answers with no sort of commentary around it. Here you're going to put those calculations into a context similar to what we did in the introduction. Right? The introduction tells you about what's going to happen in the lab. The procedure is a series of bulleted points. Well, the calculations are kind of like the procedure. They're a series of calculations with answers and no information other than the numbers. In the analysis, we're going to take those answers and those calculations and put them into more of a sentence form and explain what the calculations were. First, we found this. Next, we used this, and so on. So it sort of walks through the process that we went through. The other key pieces of the analysis are sources of error. And in this case, things like saying, I measured wrong, that's not really considered a source of error. Okay? There may be other things that went wrong. For example, we didn't have it in this situation, but let's say you were measuring density, right, of the aluminum cylinder, and I put the cylinder in the graduated cylinder with the water, the aluminum into the graduated cylinder with the water, and I took it out of the water and put it on the balance to weigh it. Well, if I didn't dry it off in between dunking it in the water and putting it on the scale, well, I'm finding the mass of the aluminum plus a little bit of water, which is going to change my data, which will then affect my calculations down the line. So that would be one potential source of error. We didn't have that in this case, but that's the sort of thing I want you to think about. What are the parts of this lab that could lead to your data being inaccurate, and then how would that affect your calculations? So this is going to be a very brief thing for this particular lab. As we get into more complex labs, there's more opportunities for error. Then there'll also be some post-lab questions, just like the pre-lab questions went in the introduction. This is the post-lab questions, they go in the analysis. And then if we had a hypothesis, which we didn't, this was again more of an answer to a question. If we had a hypothesis that we were testing and we had an expected result, we would want to talk about whether or not the analysis and the calculations, the data supported that hypothesis or contradicted it. Okay? And that's an important thing in science, is that having a hypothesis be shown to be inaccurate can be just as valuable as having it be supported. Because if it looks like it's wrong, well, then that means we figured out something that's not true, and we can take from that and rework our hypothesis. Obviously, if it's supported, that's great, and we would move on and keep testing it. But it's okay when the results of the experiment don't turn out the way you think they would. We had those accidental discoveries in the weekly discussion last week. That's a perfect example. Okay? There are plenty of times where experiments don't come out the way we expect them to, and yet wonderful things come out of it, and we learn something every time.